See, in this case, let us consider the spring A and the top part of the diagram. So this is spring A. Suppose this moves by say x1. So the spring A, the change in length of spring A is twice x1. Now let us look at the spring B. So the top end of the spring B moves by x1. The lower end of the spring B say moves by x2. So now let us look at the lowermost. Suppose here this is the block of mass m. The topmost part moves down by x2, and suppose the extension in the spring, so the extension in the lowermost spring that be x3. So this mass m goes down by this. We have to apply superposition here. Suppose this pulley is fixed, then if the spring extension is x3, then it goes down by x3. Now let us fix this spring. If the spring is fixed, if the pulley goes down by some say x2, so the mass m goes down by 2x2. So if you superpose this, so the mass goes down by, due to spring it is x3, and due to the upper pulley it is 2x2. So this is x4. That means x4 is the displacement of the block of mass m. Till now it's okay. Now to find out time period, first we will neglect gravity, because see, anyway these vertical oscillations, the time period does not depend on gravity. Now let us equate the forces in the springs. So this spring force is k times x2 minus x1, the extension in the spring, and this spring force is k times 2x1, because if you see the extension in the spring, the upper spring, is 2x1. So this is 2kx1. From this side also the force will be 2kx1, because tension in the string connecting the spring A, that is also T, or the spring force in A is equal to tension in the string. So the spring force is equal to 2kx1. So this string also has the same tension, that is 2kx1. So it is 2kx1 from both sides. So here I will get an equation, 4kx1 is equal to k times x2 minus x1. Rather, we can write 5x1 is equal to x2. Let it be equation 1. Now let us look at the spring B and the pulley. Now the spring C, the extension is x3, so, and spring constant is also 2k, so 2k times x3 force here, same force in the string, so this is 2k times x3, and the spring force is k times x2 minus x1. So therefore we can write 4k x3 is equal to k times x2 minus x1. So that means we can write 4k x3 equal to k times x2 minus x1. So here you have 4x3 plus x1 is equal to x2. So that's equation 2. And see, x4 is equal to x3 plus 2x2. So now the unbalanced force on the mass is F. See, if you see this block M, the unbalanced force is F and displacement is x4. So this F you have to express in terms of x4. Now again, let us look at the forces. See, if you see on the block, force is F. Okay. Take this pulley. So F. So you know F is equal to 2k times x3 also, because if F is same as the tension in the string connecting the spring C. F is equal to 2x. Now now I'll show it here. So this is F. If you see this pulley, F and F, so this spring force k times x2 minus x1. So we can write k times x2 minus x1 is 2F. Now again this spring, so 2F. So each of these forces F. So also we can write F is equal to k times 2x1, that is 2k times x1. So now we have to express this. So you know x1. So we'll write here x1 is F by 2k. x1 is F by 2k, and see, x2 minus x1 is 2F by k, and x1 is F by 2k. So x2 is equal to 2F by k plus F by 2k. So that is 5F by 2k, and x3 is equal to F by 2k. x3 is also equal to F by 2k. Now see, x4, as you know, x4 is equal to, x4 is equal to x3 plus 2x2. That is equal to x3 means F by 2k plus 2 into x2. So that is 5F by 2k. So it is 11F by 2k. That is x4. Now therefore F is equal to 2k by 11 times x4. So now that means the time period is equal to 2 pi root over of m by the constant 2k by, here you get it. There it is. This is the time period of oscillation of the block. And so this option is correct. Option A is correct. And if you look at option A, B, C and D, then deformation in spring A, deformation in spring C and B. See, this you can see, as you see x4. So x4 equal to 11F by 2k. This is displacement of block. Now you have to calculate the extension in spring A. Suppose, see, extension in spring A is 2x1, that is equal to 2 times x1. You have to find out from here. See, ठीक है, देखो x1 is here. What is x1? f by 2k. So here you write it into f by 2k. So therefore x1 is equal to f by 2k. So now you can compare the x4 and x1. That's what it is asking actually. So let's match it here. So let's check on option B, deformation of spring A, that is x1. x1 is 2 by 11 times x2, whether it is correct or not. So now x1 by x2, x1 by x4 ratio is equal to, then you can match it like this. Okay. So f by 2k divided by, so 11f by 2k. So this will cancel out. So 1 upon 11, it comes as 1 upon 11. So in the same way you can check it.